Hello everyone, we'll be covering data reading, saving in .npy, .npz, and CSV files. We'll also be introducing the PyTorch dataset and data loader. This is the Recitation 0D data loaders, reading and saving. Reading and saving. .npy is the standard binary file format in NumPy. It is used to persist a single NumPy array on the disk. It stores shape and dtype information. We can use numpy.save to save the array in .npy format. When dealing with NumPy arrays with varying row sizes or a list of objects or an array of arbitrary objects, we set allow pickle equal to true to save the object array. Pickle allows serialization, which lets us save the information. .npz format is for saving multiple NumPy arrays. NPZ contains multiple NumPy arrays, so we need to save the NumPy arrays with keywords, which can be the same as the variable name. That's needed for homework part 2s. So we'll be using pandas for that. We create an empty data frame using pandas.dataframe, and we'll typically have a column of indices and a column of labels. And we'll be using output.toCSV to save it as a .csv file. And we'll be using the read CSV method to read the CSV file as a pandas.dataframe object. Let's move to Dataset and Dataloader. If you are not aware, deep learning models typically require a lot of data, and being able to work with this data efficiently is quite important. PyTorch provides us with the Dataset and Dataloader functionality. And the way this works is the training data that you have is passed to a dataset class, and that dataset class creates a training data object, and that object is then passed to the Dataloader class that PyTorch provides. Dataloader helps make batches, shuffles, and does parallel processing to make the entire process efficient. The way this works is the Dataloader class interacts with the dataset class, which in turn interacts with the data. Let's move forward. Dataset class is the one that has access to the data, and Dataloader is the class which loads the data with the help of the dataset class. And for this to work, the dataset class must have two methods. The len, which is represented as dunder len dunder bracket, which is also a different way of writing the len method, and the get item, which is a way of getting item at a certain index. So it returns the processed data given an index. So the way this works is the Dataloader class asks for certain data at some index of the training data that we have, or in some cases the test data, and the dataset class accesses that using the get item. This is then passed to the Dataloader class. This is then used to create a queue of data objects, which is then processed using the collate function to create a batch. This might also have some transforms, etc., that we will be working with in the future homeworks. Some terminology. One epoch is one forward and backward pass through all of the training examples. So if this is your training data, a forward and backward pass through the entire data is called an epoch. Batch size is the number of training examples in one batch. So if assume this to be the batch size and this to be the training data, then this batch size would be the number of samples that one batch has. And iterations, the number of passes. So one pass is basically a forward and a backward pass. Now let's move on to some code and collab notebook later to consolidate this information better. The dataset, as explained above, for the dataset class to be useful, it must have two methods, the len and the get item. In addition, we do some bit of pre-processing in the init function. This is typically where we have access to the data, and this can be accessed later. We'll also be using the len to get the length of the total data, or how many X and Y pairs training samples are in your data set. The get item basically returns the data that we have at a certain index. So the get item I should return the ith sample with the order chosen by you. You should use get item to do some final processing on the data before it's sent out. But there's a caveat here. The amount of process that you do in the get item function should be as slow as possible, because the get item is called multiple times, which could be as high as 1 million depending on the number of samples that your data has. So most of the pre-processing is done in init, and the ones which, and there will be some cases that we'll be looking at in the future homeworks, which will be done in get item. Moving on to data loaders. Now, using the dataset class that you made already, the my dataset, you will pass in the training data and the training labels to get the X and Y, as was done above. You will then use that to create a training dataset object, train dataset. This, along with a set of arguments, is passed to the data loader class. As you can see, the train dataset object and some arguments, which are these. These are passed to get the train loader object. The train loader arguments are as follows: shuffle, batch size, num workers, and pin memory. Shuffle is set true for training data because you want to reduce the bias that your data might have from before. We will be going over this more in the future lectures. And shuffle is false for test data. We'll also be going through this in the collab notebook. Batch size of 256. So in this case, one batch would have 256 samples. Num workers is the number of workers that you would have for parallel processing. So if your num workers is 0, it's basically on the main process. And as you increase the number of workers, the parallelization increases. The pin memory is set true if you have access to CUDA, and it typically makes it faster. Let's now move to the collab notebook. Let's begin with the reading and saving code. So here we have a temp array, which is basically nothing but an array of size of shape 3,3, which is filled with ones. And we just save it simply using the np.save, which would then give us a tmp-array.npy in our temporary storage. So let's run the file. Along with this, you will also have the an array of arbitrary objects, which is in this case a list of lists which are of different sizes. The D type is object, so you have a list of objects, and we will be saving it using the np.save. Except in this case, we will be using allow pickle equal to true. We set the pickle equal to true because that helps with serialization and would also help us in loading. So if you can see, we now have the file saved here. When you read it, as you do here with np.load, you set allow pickle equal to true again. So npz. npz format is a zipped archive of files named after the variables they contain. So in this case, we have tmp array and tmp array pkl, which we defined above. So these temp arrays, we will save them to temp.npz, but we will be giving it to keywords because that's how we will be accessing it. And as we load, we need to set pickle equal to true because one of the files that we have, or one of the arrays that we have, the temp array pickle, is actually pickled. So once we run this, we now have accessed it, and the way we access it is using the keyword that we actually set before. There we have it. Moving to CSV, we use pandas for working with CSV and data frames. We first make an empty data frame using pd.dataFrame, and we set the column name as ID and one column name is label, which is what we will have in most cases in the homework part 2s. And in this case, we have them of the same length. So when you print it, this is what you get. You have IDs and labels. And when you want to save it, you just do output.CSV, give it the file name that you want, set index equal to false. If you don't set index equal to false, you'll just basically be getting another column which has indices in it. And then when you want to read it, so if you run this again, you'll see when you want to read submission.csv, you get a new object of the type pandas.data frame, and when you print it out, you get the same file again. So now let's move to custom dataset and Dataloader. Let's create a dataset, a dummy dataset, and for simplicity's sake, let's keep let's assume X is to be our features, which is of length 10, and Y is to be our predictions, which is again of length 10. Let's run this. So you get X's and Y's of size 10. Now let's create this as a data set. So the way we do this is we zip it together, which creates a zip object. And then we convert that into a list, which is a list of tuples. And then we access the first tuple. And that's how it works. Let's check the length, which should be 10. And now we move towards working with the PyTorch dataset and Dataloader functionality. So the torchutils.dataset is an abstract class representing a dataset. Your custom dataset should inherit dataset and override the following methods, which is the len and the get item. We also need a constructor here, which basically accesses the data and does some bit of pre-processing so that we don't have to do that while returning it, which saves us a lot of time. So we use the constructor to access the data. We use the len, which basically returns the length of the entire data set. And we use get item, which basically returns the item at some index I. You could change it. You could maybe do some pre-processing here, which would be useful. And we would be doing that in some future homeworks. Now moving forward, as we discussed before, we use this myDataset class to create an object of this myDataset type. And that is the one which we will be eventually passing through the Dataloader. Let's look at this dataset object. So as you can see, the dataset 0 is basically asking for the information at the 0th index. And that's the same as calling it with dunder get item dunder at the given index. And we get the same value at those indices. When we use the Dataloader class, we just pass this object, and notice how we have not passed any other arguments. So what would happen is we have passed an object of the dataset class that we had. And so the batch size should be 1, and the shuffle will automatically be set to true. So when we access X and Y, we would get a PyTorch tensor, because that's what PyTorch works with, a PyTorch tensor of type of X and Y, which will both be of length 1. And so that's what we get, 0 and 10. And since shuffle was set to false, they're in the order that we had created the data set. Now, let's pass a batch size of 2. And in this case, what we would expect is that the length of X and Y would be 2, because we have passed a batch size of 2. So, and that's what we get. So we get X, which is 0, 1. So this 0, 1. And Y, 10, 11, which is this 10, 11, to be the batch size. So batch size, and this would be your training. In this case, assuming X to be your training, this would be a training and a training data set, training data, and 1011 would be your labels. Moving forward, we could also use the enumerate function, which basically works the same way as the loops above, except that it gives us the index as well. So the index and x comma y. This is really useful if you want to want to stop at certain iterations, or basically just know the number of iterations that have happened till now. So let's run it, and you get the indices along with the tensors as you were getting before. And notice how we said shuffle equal to true. So the tensors are not in the order that we had set them, which was 0 to 9. In this case, we have them in a shuffled order. In this case, we now have some train loader arguments which we will be passing to the data loader along with that object of dataset type. So our arguments are shuffle, which is set to true, batch size, which is 2, num work is equal to 2, so we have parallelization, pin memory equal to true. This should be faster. And once we have this, we can just print it out the way we did before. And there we have it. Because it was shuffled, it's now not in the order that we set it. And we have indices because we used enumerate. And because we use num workers and pin memory, we can't really see it because the data set is really small, but this would typically make it faster. All right, let's move and work with a different data set, which is the fashion and miss data set, which is a data set that PyTorch provides on its own. Torchvision, more specifically, Torchvision provides it, and it's basically a sequence of images which contain some clothes, and the image sizes of 28,28. Let's run this. So I have saved it from before, and we don't have to worry about it. Let's visualize these objects and see. So as you can see, the labels are given here: t-shirt, trouser, and basically other clothing items. And this is what they look like. So this is the data set. PyTorch provides us the data set on their own, so the data set class is given to us, and we can access it directly. So now if you want to use the data loader, we have the dataset object because PyTorch provided it on their own, which is this training data. We can now pass it to the data loader, set a batch size of 64, set shuffle equal to true because it's training, and a test one and set shuffle equal to false. Let's now visualize this data. So the way we do this is the data loader object is basically, it can be accessed using the iter function, the Python's iter function, which basically returns an iterable. The way you iterate over it is you use the next method. This would basically give us one batch of training data, and then we can now let's run this and see what happens. So if you see, the batch size is 64 because that's what we set it as. 1 is the number of channels. So in this case, since it's black and white, the channel is 1. If it's RGB, it goes to 3. 28,28 is the size of the image. And the labels, because there are 64 images, is 64. Let's move forward. So if you see now, since in the previous case we had a dataset class which PyTorch provided on their own, let's try to create a dataset class of our own. So for this case, let's create a dataset first. The way we do this is we have two empty lists. We populate them with the training data that we have already, and we convert it to NumPy. We do this because we are looking at we're creating our own data. And once we have that, we can save it to NPY. And for collabs case, then you can see what has been stored right here. So in this case, we just stored it as using numpy.save as we did before. and you now have images npy.npy and labels npy.npy here. Now let's create our own custom dataset class. As explained before, the dataset class should contain a constructor in it, which is here, which basically accesses the images. So it does np.load on the images npy and np.load on the labels.npy. And then you have a len function, which basically returns the length of the data set. So we basically get len of self.image labels, because those are the number of images we have. And we do we populate the get item, which basically gives us the information at a given index. In this case, we are not processing anything, so we just return it as it is. Now here we'll be looking at the collate function. The collate function typically helps us get the training and test from the batch. And so in this case, we have the batch given to us. We first zip it to get the x's and y's. And now we process it. So for demonstration, we are padding the images. In the future homeworks, we'll also be doing some other processing in the collate function. So let's run it. And now, since we have padded it by 20 on the borders, the image size should now increase. So let's now create a dataset object using the custom image dataset that we have. So we passed the file locations to the constructor like we did as the constructor required. We now have a training data custom object. And now we'll also add some arguments. So the batch size, shuffle is set to true, because in this case we're dealing with the training data. Collate function, in collate function we pass the collate function for the image, for the custom image dataset. So we pass the collate function for this object. You could also define it separately if you want, and then we pass it to the Dataloader function, and we get the Dataloader object. If you've been observant till now, you will notice that there's a common pattern here. Basically, you have your, and this is, if there's one thing that you need to take away from this recitation, it is that in most cases in the homeworks, you'll have a custom data set. That's what you create. To create that, you need the len function, the get item, and in collate function is not really required, but depending on the use case, you might have one. You do most of the pre-processing in it. You do some in the collate depending on what you need to do, maybe some padding or something like that, and then you return it using get item. This dataset, a custom dataset, is then used to create a dataset object that is passed to the data loader along with a set of arguments. And that's basically how the dataset and data loader works. So again, we'll use the iter function to create iterable, and then get next to basically create an object. That is, then we then can take the first one, because we're taking the first image in the first batch, and then we squeeze it, because we want only the we aren't really concerned with the channels, and then we plot it. So in this case, as you can see, the size has actually increased from 28,28, which was here, to something more. Here we have the references that you can follow for more reading, and that's it. Thank you.